Okay, so on page 150, this is where we left off yesterday. We, based on the information we had here, wrote a system of inequalities and then graphed each of our inequalities to talk about solutions here. So in the context of our problem, we were, I think, a toy company making toy trucks and toy cars. And we have a certain number of wheels in stock, and we know we need so many wheels for every car and so many wheels for every truck. However many wheels I use making my cars and trucks cannot exceed the amount I have in stock. And then we had a similar issue with our seats. We knew we had 100 seats in stock. I needed so many seats for every car and so many seats for every truck. And the amount of seats I needed to complete all my cars and trucks could not exceed the amount I actually had in stock. So that's where we got our two inequalities. And then we graphed each of these inequalities. And we said the number of cars and trucks that we could actually complete, that we could actually manufacture, would be in that double shaded region. So for example, I could make 20 cars and 30 trucks, because that's the point in that double shaded region. I could make 30 cars and 40 trucks. I could make no cars and 30 trucks. All of those are points in that double shaded region. So all of those would be options. All of those would be solutions to our system of inequalities. Questions from yesterday? Okay, so on the next page, we're going to take a look at some more systems of inequalities. We'll start off just with some graphs, and then we'll look at another problem in context. So if we take a look at our first example, we have two inequalities there. So we're going to graph each of them and then identify where we'll see solutions. So for our first equation, we have y is greater than x plus 2. This is slope-intercept form, so I'm going to start by plotting that y-intercept of that positive 2. And then my slope is 1, so I'll go up 1 over 1 to plot my points. I want to make sure I fill the graph so that I can see particularly where we're going to have shading, so that I can see where my solutions will be. So I've plotted points for this line. Now I need to know if I should have a solid or a dashed line. How do I decide that? Solid or dashed? Dashed, why? Exactly right. This is strictly greater than. If it's just greater than or just less than, we've got dashed. One thing I said to one of my earlier classes today was if you see a line, Cam, this is kind of what you said, it doesn't have a line underneath it. If you see a line, then you're going to draw a line. But if we don't have that line underneath, we'll be dashed. So I'm going to fill in some dashes here for this guy. And now I need to know where to shade. So I talked about this yesterday. Some people are really great at looking at y is greater than and knowing I'm going to shade here, or seeing y is less than and knowing I'm going to shade down here. But if that's something that is trickier for you, then we can pick a point and test it to see where to shade. So that's what I'm going to continue to do today, just as that reminder that you have that option to check your shading. So I'm going to, again, pick a point that is not on the line. Okay, I need a point that is not on the line. I like to pick 0, 0 if I can. So that's the point I'm going to pick. So I'm going to take 0, 0. And I'm going to plug those x and y values into my function and see what I get. Into my inequality, I should say. So this would be 0 is greater than 0 plus 2. So 0 is greater than 2. Is that true? No, 0 is not greater than 2. That means I do not want to shade on this side. That point doesn't work, so nothing on this side will work. So I'll shade on the other side. And now that I've graphed my first inequality, I'm going to graph my second one here. So for our second inequality, y is less than or equal to negative 2x minus 1. Again, we have slope-intercept form here. So I'm going to plot my y-intercept at negative 1. And then my slope is negative 2. So down 2 over 1, down 2 over 1. and then reverse that process to get some points back here, up 2, back 1, up 2, back 1, up 2, back 1. Remember, we want to fill the plane. Solid or dashed line for this one? Solid. If you see a line, draw a line, right? That or equal to means points on this line are included. So we want a solid line here. And now I need to decide where to graph. 0, 0, again, is not on the line, so I'm going to pick that as my test point again. So when I plug that in, I would have 0 is less than or equal to -2 times 0 minus 1. -2 times 0 is 0. So 0 is less than or equal to -1. Is 0 less than -1? No. Or equal to, I guess, but it's also not equal to. So that's another no. So again, I want to shade on the other side. Since that point didn't work, I shade on the other side. My solutions then are in this double shaded region here. So any point in that double shaded region would be a solution to this system of inequalities. Questions for me on that first example? Okay, let's take a look at number 2. Again, I have a system of inequalities here. My first one this time is in standard form. I'm going to go ahead and rewrite that in slope-intercept form. Yesterday, we reviewed how to graph from standard form. I could change it to slope-intercept, or we can find the x and y intercepts on the graph. What I've seen from most of your work on quizzes and tests is that you guys in general prefer to change it to slope-intercept form. So that's what I'm going to do as well. I'm going to start by moving that x to the other side. So we would get negative y is greater than negative x plus 4. And then to get y by itself, I've got to divide everything by -1. Remember that for inequalities, when I multiply or divide by a negative number, I have to flip that inequality sign. So here I end up with y is less than x minus 4. Since we divided by a negative, we have to flip that sign. Now that this is in slope-intercept form, we have our y-intercept that we can plot. So 1, 2, 3, 4, down at -4. And our slope is 1, so up 1 over 1 to plot our points. Again, remember to fill the coordinate plane with graph. And then solid or dashed here? Dashed. My last step here is to decide where to shade. So again, I'm going to pick that test point, and I'm going to pick 0, 0 again because it's not on the line. So 0 is less than 0 minus 4. So 0 is less than -4. Is that true? No. That means I want to shade on the other side. So down here. Now for my other inequality, we don't have a y here. This is just talking about x values. So if we were on a number line and we saw x is greater than or equal to 1, we would go to 1, put a filled in circle because it's could be equal to, and then we would shade everything bigger than 1. Since we're on a coordinate plane, we're still going to go to where x is 1. But this time, instead of having to stay on the axis, it applies to everywhere on the coordinate plane that x is 1. Since it's or equal to, this would be a solid line that would follow right on top of this grid line. This grid line I have here is everywhere that x is 1. So we're not just in one dimension here on the number line, but since we're in 2 dimensions, I would go up and down with that as well. And then my shading, just like on our number line, we shaded everywhere that x was greater than 1. Here we would also shade everywhere that x is greater than 1. Again, not just on the axis, but everywhere on the coordinate plane that x is bigger than 1. And our solutions, again, would be in this double shaded area. Questions for me on example 2? Okay, so we're going to take a look at one more example together today. If you'll turn the page for me. Looking at a problem in context again. So we're going to create our system of inequalities here, graph and identify some solutions. So example 3 says Dunkin' Donuts is selling bagels for $1 and donuts for 50 cents. Sophia wants to bring baked goods to a meeting. She knows that she wants to bring more donuts than bagels and has $20 to spend on treats. Let X equal bagels sold and Y equal donuts sold. So this is sort of similar to that problem you had on your quiz last week. You had something about tickets sold, I think, adult tickets and student tickets, and you knew how much money you made and you knew how many tickets you sold. So you wrote a system of equations and then solved that system to determine how many of each type of ticket you sold. So if I take a look at this problem, I have some similar information. Just like with that quiz problem, you had information about how much each type of ticket costs. Here we've got information about how much each type of baked good costs. We know bagels are $1 and donuts are 50 cents. Since X is bagels, I know it's $1 for every bagel and 50 cents for every donut. Y is donuts. And then I know the total amount of money I have to spend. I have $20. Now, for your quiz problem last week, you knew exactly how much money you made off of your ticket sales. So we put an equal sign between these things. But here we're talking about money I have to spend. Do I have to spend all $20? No, I could spend less than that. So this amount that I'm going to spend on donuts and bagels needs to be less than or equal to 20. I could spend all $20, but I don't have to. So there's my first equation. And the other piece of information we have sort of relates the donuts and bagels to each other. So she wants to bring more donuts than bagels. So that means I want however many donuts I buy and bring to this meeting to be greater than however many bagels I buy and bring to this meeting. So there's my system of inequalities. Now, before we start graphing, I want to ask you a question here. If I take a look at my coordinate plane down here where we're going to graph our system and then I eventually identify our solutions, we know X stands for how many bagels we're buying and Y stands for how many donuts we're buying. Excuse me. I've only given you the first quadrant here of the coordinate plane. Why? Can't have negative what? Yeah, if we look at that, that's where we have to be careful with that label that we're saying can't be negative. So X is representing number of bagels. Y is representing number of donuts. What would a point over here mean? I would have a negative number of bagels, right? Is that something that makes any kind of sense? No. Like I showed up at Dunkin' Donuts and like made them take some bagels from me. No. So we're going to be just in this first quadrant here. And actually, if we go back to our toy problem, we were just in the first quadrant there for the same reason, right? It doesn't make sense to talk about producing a negative number of trucks, okay? We're going to stay in that first quadrant because we can't purchase a negative number of donuts or bagels. So let's go ahead and graph our system here. I'm going to change this first equation into slope-intercept form. I'm going to move that x to the other side. That would give me 0.5y is less than or equal to negative 1x plus 20. And then to get y by itself, divide each term by 0.5. So that would give me y is less than or equal to negative 2x plus 40. My y-intercept is 40, and my slope is negative 2. So I'll go down 2 over 1, down 2 over 1. Solid or dash? Yeah. Only if I divide by a negative. Multiply or divide by a negative, we flip that sign. But if it's a positive number, I don't need to. Solid or dashed here? Solid. And then I need to decide where to shade. I'm going to test my favorite point, 0, 0 here. So that would be 0 is less than or equal to negative 2 times 0 plus 40. So 0 is less than or equal to, that's just 0, 40. 0 less than or equal to 40? Yep. So we're going to shade this little like triangle of space down here. And then we'll graph our other inequality. So this is also slope-intercept form. We have a slope of 1, and our y-intercept would be 0. So I'm going to plot my y-intercept there. And then up 1 over 1, up 1 over 1. Solid or dashed line here? Dashed, very good. And then I need to decide where to shade. I cannot use 0, 0 this time. That's a point on the line, so I cannot use 0, 0. So I'm going to use 0, 10. When I plug that in, I would get 10 is greater than 0. Is that true? Yep. So I'll shade this side. This point right here. Oh, you could check the point 10 comma 0. It's not going to work, which will tell you to shade the other side. Does that make sense? Okay. Okay, now I would like you to identify 2 possible combinations of donuts and bagels that you could take to this meeting? Anybody want to give me one option that they had? Number of donuts and number of bagels? 20 donuts and 10 bagels. That would be this point right here. Since it's on the solid line, that's okay. That would work. Anybody else want to give me an example? Number of donuts and number of bagels? Nevada? 0 bagels and 10 donuts. So no bagels at all, 10 donuts right here. Yep, that would work. Questions for me? Okay, so for the remainder of our class time, I want you to work on your homework problems on page 153 and 154. So you've got some practice graphing and then some practice with a couple of those context problems. And you also have a short Delta Math assignment that again is going to have you practice graphing those inequalities on their own as part of a system, and then a couple of those in context problems.